I told you, OSC is like a UDP-based protocol, so it works a bit like a queue. So you send a message, the message is in the queue, and then another component of the application just take the message that it needs to take. So, but this UDP level is just, you can just go on any computer this way. So we did a lot of different, we'll show you a lot of different things based on that. So okay, so we will now continue in this ID. Because there it was just the connection, but now what we will do is that Conti will like really try to steal the namespace of one of the components. So you will now stop the polynus. So we will now stop the tracker. And what Jonty will do is that he will actually replace the polynus namespace by another iPhone application, which is like a 2D mapping, a 2D map that he just like put his finger to change the value. So we have to restart the audio. We can do it. And the mapper. Yeah. So I have to wear this gesture, which is the ball gesture, but now Jonty is controlling the ball space. Just again, if you look at the code, it's just like you don't see anything. It's just like transparent at the coding level because it's OSC. And so we can start to like play together. So now it does not control anything else than the pitch. And it's back on the ball space. It's such a lot of fun like this. Okay, so you see that this idea of stealing a namespace is really useful when you have your system, but you quickly want to try a new controller. So the only thing you have to do about this new controller is to redefine an OSC namespace around your new controller so that it steals the namespace of the one that is already implemented. And you can, I mean, we did this in even, did you take 1 hour to do it? Yeah, something like 1 hour. It's like, okay, I have a new controller that I can try. Then eventually you move to the real coding when you are happy about the result. But that's a really important step for research. So we can do that for the controllers, that's what we showed you. But you can do that for any component. So now we will do it for the mapper. And we will also show you another feature, which is the synthesizer is also became a kind of really pluggable and unpluggable component. So but actually Jonty already showed it like without mentioning it, but you can just switch the synthesizer without stopping the application. So we were on the home synthesizer, which is a Formant, like a really classical Formant synthesizer. And now we can switch onto the Ramses synthesizer, which is my PhD synthesizer, which is also a kind of source filter synthesizer, but a bit more complex, so it's sounding a bit better for singing. So Jonty will show you that you can directly just switch between these two things. Yeah, this is Holmes. Now we are back on Ramses. You see, you just don't stop anything, you just unplug and replug it. And so now we will also show you a new mapper, because this is the RBF basic mapper. We stopped it. So he re-implemented a mapper on this mobile device, which is like he will explain it better that you explain.
Yeah, it's just a simple 3D controller. You have 2 points of touch on the surface. It just controls the volume and then the frequency and then the amount of vocal effort.
Okay, so now I will show you. We'll show you something which is fairly the same, except that to add some even more complexity to the context, Jonty will use the controller on his laptop. This laptop will run the mapper, and this laptop will also run the synthesizer. So it's like we started to break everything on different platforms. So here, simply, no, you have the mapper actually. Yeah. So Jonty has the mapper here. So we drop the RBF, we go into another kind of paradigm, which is for singing. And Janti is controlling the same synthesizer with a new mapping strategy on the magic trackpad.
So I've had like 10 minutes of practice on this.
So if anybody wants to, this one is really addictive. So if you want to try it, can you make the emergency thing? So it's not always working that fine in the sense that what I will do right now, I need to stop the Diva application because I will rewire something on this component. So I really you need to actually shut down the server, just type any kind of keystroke and you say enter and you stop. Yeah. Okay. So now what I will do is just to stop this. And you can also shut down the UI. Just waiting. It's back. Green light, green light. Yeah. So you can now restart both. We didn't just do that for making fun with iPhones, actually. We have some plans for the next, let's say, forthcoming mapping strategy that we want to use for the Diva. One of the big issues of the Diva right now is the foot pedal. You have a foot pedal to actually trigger the volume. And it's not really handy because first, you cannot move. You cannot really move because it's really influences what you are doing. And it's really, we had a lot of troubles to actually adjust it so that it's working really fine. The feet is a bit like tricky to be precise with, especially when you have the shoes and a costume and everything. So we tried slowly to think about getting rid of the foot pedal and to put back everything into the ends so that you would control the volume and more generally what you call the source of the voice, so the larynx, like the pitch source and tension from ends movements. And so it's we will show that through this example in the sense that we didn't want to recompile everything to just like to mess up with the code. We really want quickly to have an ID, so we keep this application. But again, we just bridge the mapping strategy with another one, which is the max patch, which is in the folder. So if you go back in the folder, you have a max patch called new polymus mapping. And so we started. You see that it's just a max patch. Now you can go back to the connection of just the audio, because that's the only component. Oh, no, the polymus first. Yeah. So select the first, connect it. Now you should have like the whole thing that moves, because we plugged the two receivers. And we will just bridge everything and just start the synthesizer. And you will switch it to the bounces. So the switch does it. Yeah. And so now what we have is that we have a polymus, which is, again, just updating the state. We have the patch, which is doing the mapping, which is what I will show you right now. And then it's back to the Diva for synthesizing the sound. And what we try to explore with this example is actually at the volume. That's a really interesting and intuitive gesture that Cam did one day when we were discussing about it. Say, for me, volume is just doing this. If I no volume, big volume. It seems pretty obvious, but when he told us, okay, that's right. So that's what we did, and you see that in Max, it's just a few objects to tie together. So basically, now we have a mapping between two sources of polymus that when you just, oops, okay. Oops, I'm just crossing the source, I guess. Pretty easy. So we said, okay, what else can we do? We can, of course, have the pitch. Then my synthesizer handles in a really interesting way the tension, the vocal fold tension. Soft voice, tense voice. It's just an idea. You could make it like the angle or whatever, but here we just like map the one axis to the tension. And then I think one last thing that I did is just to say, let's get just the regular notes. When you sing, you want to sing it in tune. And so when you move like this, it's really difficult to be in tune, as you can imagine. So let's just, when you move like this, let's just have the regular notes that are the perfect pitch. So you don't have the continuum, you just have the perfect notes. And if you want to modulate, and the typical modulation in singing is vibrato, if you want to modulate, you just shake your hand.